Alright, AP Cal students. Today we're going to be going over and taking a look into an example of orthogonal curves. So we could define two curves are orthogonal at a point of intersection if the tangents at that point cross at right angles. So our problem states, show that the curves 2x squared plus 3y squared equals 5 and y squared equals x cubed are orthogonal at 1, 1 and 1, -1. Following the definition of orthogonal curves, we can infer the curves 2x squared plus 3y squared equals 5 and y squared equals x cubed are orthogonal if their slopes at 1, 1 and 1, -1 are perpendicular to each other. And because they are perpendicular, their slopes must be negative reciprocals. We begin by taking the derivative of curve 1, which is 4x plus 6y dy over dx equals 0. We subtract negative 4x on both sides to get 6y dy over dx equals negative 4x. We divide 6y, so our dy over dx would equal negative 4x over 6y, which can be simplified to negative 2x over 3y. We continue by taking the derivative of the second equation, which is 2y dy over dx equals 3x squared. We divide 2y on both sides to get our answer as dy over dx equals 3x squared over 2y. So what did we find? We found two equations for both curves that allows us to find the slopes of the tangent line at both 1, 1 and 1, -1.
To find the slope of the tangent line of curve 1 at points 1, 1, we must use the derivative of the curve, which is negative 2x over 3y. When we plug in the points 1, 1, we get the slope of negative 2 over 3, which is the slope of the tangent line. Then we must find the slope of the tangent line of the second curve at points 1, 1. To do so, we must use the derivative of the second curve, which is 3x squared over 2y. We must plug in the points 1, 1 into that equation, and we will get our answer of 3 over 2, which is the slope of the tangent line. As we can see, the slope of the tangent line of the first curve is negative 2 over 3, and the slope of the tangent line of the second curve is 3 over 2. These slopes are negative reciprocals. And when the slopes of two lines are negative reciprocals, it means that the lines are perpendicular to each other. To find the slope of the tangent line of curve 1 at points 1, -1, we must use the derivative of curve 1, which is negative 2x over 3y. We plug in the points 1, -1 into the equation and we get our slope, which is 2 over 3. Then we must also find the slope of the tangent line of the second curve at points 1, -1 using the derivative of the second curve, which is 3x squared over 2y. We plug in the points 1, -1 and we get our slope, which is 3 over negative 2. As we can see again, the slope of the tangent line of curve 1 and 2 at the points 1, -1 are negative reciprocals. This means that the tangent lines of both curves are perpendicular to each other. As we can see, the tangent lines of curves 1 and 2 at points 1, 1 and 1, -1 are orthogonal because the lines at those specific points are perpendicular.